This question is question 3 in year 2017 College Board AB Calculus AB. We want to look at it and answer it, try to explain it. So they give us a graph, and this graph for function f. And they tell us there is another function g, and function g is the integral of function f between 1 and x with respect to t. They want to find the average rate of change of g from -5 to 5. So before we start to answer question part A, we'll tell you, when you see this form, g equals the integral of f, you think right away that f will be the derivative of g in this period. So because we're going to use it in different options. So the first one, find the average rate of change, means they want to find g of x2 minus g of x1 over x2 minus x1. And this reflects that we need to find the integration from -5 to 5. The integration means the area under the curve. The area under the curve, we have positive part and negative part. Positive part and negative part. So the positive part is above x-axis here. That's the positive part. And any area under x-axis will be negative part. That's the negative part, and this is negative part. Quarter circle, and this part too is negative part. Yeah. So we want to calculate the area from the given graph. So what we could do here is to find the positive part, which is, it looks like a trapezoid, base 1 and base 2, and this is the height here. So if you remember the area of the trapezoid, it's a half base 1 plus base 2 times the height, and base 1 is 2 units, base 2 is 1, 2, 3, 4 units, times a half, times the height will be 1, 2, 3, 4. 1, 2, 3, 4, 4. So this will be 6, and a half times 4 is 2, 2 times 6 is 12. So this part, the positive part, will be 12. And here we have 3 sections here, 1, 2, 3, 3 parts under x-axis. All are negative. So let's calculate the first one. The first one will be the half base times the height. It's a triangle. Half base times height. Half times the base is 3 times the height is 3. 1, 2, 3, 4. Calculate that. 3 times 4 is 12 divided by 2 is 6. So this unit is 6, but it should be -6 because it's under x-axis. And let's go for the easy one. Half base times height, half times 1 unit. Here you have 1 unit times the height is 2. Then 2 cancel, 2 and 1 left. So this is -1. And now the quarter circle. As you know, that the circle is pi r square. So we'll do 1/4 because this is a quarter circle. The radius of that is 2. The radius of the circle is 2, so 2 square pi, and here is 1/4. 2 squared is 4 times 1/4 cancel, is 1. Pi left, so this is -pi. So this expression, which is g of 5 minus g of -5, and divided by 5 minus negative 5. Minus negative 5. This part will be represented as the integral result. The integral result will be 12, which is positive, and you have negative 6, negative 7, and negative pi. So negative 6, pi, and 1. So it's 12, and 6 plus 1 is 7, so it's going to be negative 7 plus pi. Finally, 12 minus 7 is 5 plus pi. So this part will be 5 plus pi divided by 5 minus negative 5. 5 minus negative 5 is 10. So this is the answer for part 1. The answer for part 1. Yeah. 6 and 1 is 7. 7 plus pi. We have to subtract pi here. This is minus. Sorry for that. This should be minus. So it's 5 minus pi over 10. Now, let's go over part B. Part B, let's move it up to look at it, the graph. And we finish the graph to be used for part A. We need it now for part B. So part B, find the instantaneous rate of change of g, function g, with respect to x at x equals 3. Instantaneous rate of change means they want to find the opposites. They want to find function f. Look at this. F of t, we'll do that here. So we'll do f of x, the derivative equals g of x. Yeah. And if you do that here, the derivative of g will be f of x. We integrate it. So if you want to find f g dash of 3, the instantaneous change, rate of change at 3. So you're going to find f at 3. All you have to do, you have to recognize that, and then you decide to go to the graph and look at 3. 1, 2, 3, go up to meet the graph and look at the value of y will be 1, 2, 3, 4, it's 4. So the answer of this question is 4. That's what I need from you to do. That's part B is done. Now part C. Let's grab part C up a little bit here. They're talking about concavity now. On what open intervals, if any, is the graph of G concave up? Justify your answer. They're looking for a graph of G, but actually we have graph F. So how do we do that? Concave up means the derivative increased. The derivative increased, concave up. Since we have, first, we have to put this assumption here. G dash of x, derivative of g, equals f of x. And increased where? Increased where? So you have to look, we don't have the graph of g, we have the graph of f. That's fine. So where is the graph of f increase? We see that the graph, yeah, look at it. Looks like I hear you. You're talking about this part of the graph and this part of the graph. It's from negative 5, 1, 2, 3, 4, 5, from negative 5 till negative 2. So from negative 5 to negative 2, the graph of f increased means the change of g increased. So this is from negative 5 to negative 2. This is part 1, negative 5. So from negative 5 to negative 2, or you could say negative 5 is less than or equals x is less than or negative 2. It's up to you. Yeah. And also, if you look at the graph, you will find that the function f or the derivative of function g increased from 0 till here. 1, 2, 3. 1, 2, 3. So increase from here to here, from 0 to 3. So the second here, it's 0 till 3. Or you could do 0 is less than or equals x is less than or equals 3. Periods of increasing, so that means concavity. Concave up. That's the part C. The last part of this question, they ask about find all values in the interval from negative 5 to 5 at which function g has a critical point. Classify each critical point as the location of a local minima and local maxima, or neither. Justify your answer. So we'll see. Look at the graph here. We still look at the graph. They tell you g, and you know g, the derivative of g equals f. So it's ready. You don't have to take the derivative of f. It's ready already. The derivative of f is in front of you, which is the derivative of g is in front of you, which is f. Critical points. That's the derivative. So assume that this is derivative of g. As you know that this is the graph of f, it's the same as the graph of g dash, the derivative of g. And we must have 0. As you know, critical points, you take the first derivative and equal to 0. So we're going to look at where is the graph has a value of 0. You see at here. This is one of the at 1. And also at negative 2, critical points. At negative 2. So you're going to say that. So you're going to say, okay, f or g dash of x equals 0 at x equals the following from the graph: 1 and negative 2. 1 at 1, and also x equals negative 2. So you have 2 locations for the critical points. And now you want to justify local minima and local maxima. Okay, look at this. We finished that. Remove it to look at the graph clearly and find local minima or maxima. Yeah. If you look at this critical point or that critical point, at 1, the situation is easy to tell that you have already potential for local maximum. Local maximum. Why? Local minimum. Yeah, local minimum. Because the graph before it was negative, and then after it is positive. Let's explain that. This area looks like, when you graph it like that, let me erase this part to show you. Here. When you have this curve, and this is our critical point, you see the slope here? It's negative. And you see the slope here? After it, it's positive. So negative before and positive after. This is local minimum. So the graph has potential of local minima at x equals 1. Conclude that. At x equals 1, local minimum. Explain why. Explain why. Because g dash is less than 0 when x is less than 1. And g dash is greater than 0, positive means. This is negative and this is positive. When x is greater than 1. That's your explaining. When you come to the second critical point at -2, you will see that both before and after the graph in negative area, and here is after it in negative area. So no change. No change in the derivative. And here is, you will submit that. No and no. No local minimum, neither local maximum. At x equals -2. Why? Because no change before or after. No change. This is the answer of question 3, year 2017. I hope you best luck in your test.